Yeah, so once we have added both the antennas into the simulation, the next step is to designate potential locations for the installed antenna by defining their placement candidates. There are a few methods for defining a placement candidates. In this case, we'll use the two-axis system, where we'll select the antenna axis system and the platform axis system, and the app will superimpose the two axes at the position a placement candidate will be defined. So we'll position the antenna on the exterior surface of the fuselage. The VHF antenna will be placed at the front, middle, and rear of the passenger cabin. As you can see, now we have 3 placement candidates for VHF antenna. And similarly, the glide slope antenna will be placed at the bottom of the passenger cabin, where Naomi, our CAD designer, has already created an access system. So after we have created these placement candidates, we will use a very interesting tool called the obscuration plots. So these plots show how the aircraft's geometry obscures the area of evaluation of each placement candidate. The area of evaluation that is obscured by the aircraft, which is also known as the blockage area, is a good indication of potentially limited antenna performance in that region. So these plots are useful because it gives a very quick judgment about a candidate's potential to perform well during a simulation without running a detailed electromagnetic simulation. As you can see, you can view the results in 3D as well as in a 2D plot. And so once we are done with the antenna placement, we can move to the simulation setup step of the workflow. So after we have defined the model of the antenna placement simulation, we will define the scenario. We'll start with defining the antenna group, which specifies the set of antennas and their operating frequency. In this case, it's 0.1 gigahertz to 0.4. And then we can go ahead and configure the simulation, where we can customize the simulation settings in CST Studio Suite. CST Studio Suite automatically loads the assembly required for the simulation and lets you customize settings such as mesh type, solver type and accuracy, and platform material. And any changes we do in Studio Suite are updated automatically to the 3DEXPERIENCE platform, ensuring accessibility and continuity in the antenna placement app. So this is an optional step. So if you choose not to customize the simulation setup, the default settings will be used during the simulation. And now, since we have set up our simulation, we have did a bit of customization. We can switch to the coverage analysis. In the coverage analysis step, we will create and simulate coverage tests for the VHF and glide slope antennas at their installed position. To define a coverage test, we will select the antenna group which we defined and one of and the position of the antennas. So we'll define 3 coverage tests, one for each combination of the VHF and glide slope antenna placement candidates, as you can see. So now we have defined 3 coverage tests. And at this time, I would like to now move to the antenna placement app, where maybe we can have a look how this is done in the app. So this is the same example. I've set it up. On the left side, you can see is the navigation tree. And this displays a hierarchical view of the simulation models data. So the platform is here, the antenna, the candidates, and so on. And you can see where the candidates are placed on the platform. And on the right side, you see an assistant panel. it displays a set of actions that you can perform in the order it is presented to complete a simulation. So far we have seen that we have performed all these actions until the defined coverage tests. So now, since we have defined the coverage test, the next step would be to configure some output requests. So here we can specify what kind of KPIs are we interested in, so that the solver can generate, and we can also select some sections for the radiation pattern. So after defining the output, we can proceed to simulate the coverage test which we have defined. In here, so this dialog provides you a way to select which coverage test you want to simulate. So in order to save time, I've already simulated the coverage test, as you can see here. And this is also seen in the navigation tree on the left with these green thumbs up icons on the results, so which suggests that the results are available and are valid. So once we have the results, we can go ahead and view them. So the antenna placement app provides access to various tools which can be used to review and evaluate the performance of each installed antenna. So the radiation pattern plots, they display the far field directivity in section planes. So let's look at the horizontal plane at the frequency sample 0.31 for the 3 coverage tests, and let's try to compare them. So you can very easily compare section planes for the coverage tests you've simulated at different frequency samples. The performance indicators, this lets you compare the KPIs in a dashboard. And here I've already opened it for you. It shows a very tabular form where all the KPIs you have selected to be generated by the solver are displayed for each of the coverage tests, and you can very easily compare and do a trade-off study. And last but not least, the scattering parameter. This lets you review the coupling between the various antennas, and here you can easily view the coupling, and as you can see, this is in the range of 0.1 to 0.4 gigahertz, like we previously selected. So when we combine these tools, we can make a comprehensive quantitative and qualitative judgments about the installed antenna performance. And I guess with that, the installed antenna step for this workflow is done, and I would like to hand it over to the systems engineer, Carlos, and who will talk about the interference analysis.